Hi everyone, my name is Owen Donnelly, and I spent my summer as the manufacturing engineering intern at the Stryker plant. This isn't my updated one. Okay. I'm going into my third year at Bowling Green State University, majoring in mechanical and manufacturing engineering technology. This summer I got the opportunity to work under Steve Knopfsinger at our Stryker plant, as I said before. And he came into the summer with me, even though it wasn't really a pre-planned position with plenty of projects to work on. My first project that I worked on was creating standard of procedure documents for our parts, cells, machine setups. Currently, Paul Liu is our guy who does it. He does our our machine calibration, bit changes, everything that we need to do for each different part on our machines. Currently this is all tribal knowledge, so it's kind of just Paul that knows it. A couple other people kind of know a basis of what to do. So my main project this summer was to create documents for this, for the inevitable day that we lose Paul and he retires. I spent my summer following him around with the camera, taking down notes so that I can make clear, standardized standard of procedure documents for his entire process to at least assist the future person who takes his position. Another document-heavy project I worked on was giving our Cutlass binder for the solid surface tell a full reface. Over time, this binder became just a mix of handwritten notes, different templates, kind of outdated measurements that our operators slowly learned to be incorrect. So Steve tasked me with making everything standardized, clear cut, and I took this opportunity to organize everything, add in the operator's notes so that it was documented electronically, and then also adding some extra information that they said would help them in the future to make things go quicker and smooth. And I had a couple of projects that weren't really planned for me, just kind of came about. The first one being the router guard. Paul had an idea for a guard that could completely cover our router bits, but when feeding material, move out of the way for the operators so that there was little to no interference with feeding. He came to me with a wooden mock-up, asked me to help design it in CAD, and from there we kept working on it using the new product development 3D printer. We went through multiple iterations with different spring tensions, spring sizes, everything of the sorts. We did extensive strength testing with the guys at NPD of different manufacturing processes and materials, different printing methods, and we found that with 3D printing, what we could get with static force was up to 300 pounds of force before failure. So that was really good, and I think that information can really benefit and help whoever has the executive decision how to manufacture for the plant make their decision. This project that project with the router guard kind of opened the doors for me to work on other projects of the sorts with lots of modeling. Steve came to me with an idea for these capital glider arm caps that have two concave shapes to them, making it kind of almost impossible to use on a table router. So what operators were doing at the time, they were holding the part in one hand and with their other hand using a hand router, which for the new safety standards that have been being implemented really is not ideal. So Steve asked me to find a way to mount these or to hold them down for our operators to continue using the hand routers. And through my process, I found that we have a vacuum table pod that you just have to hook up an air hose to, and it creates a vacuum. So I modeled and 3D printed a form that follows the concave shapes to a T perfectly, and then we use the solder woodworking 3D printer, as it's bigger, it can do bigger shapes, to 3D print this for us. We came into a couple issues, the biggest one being that we found out 3D print material is porous, but with just coating it with clear coat and sealant, that issue is fixed right away. And from there, it worked pretty well. I just made a couple changes from our first one to the second one of adding these clips so that when the vacuum is off, the mount doesn't easily move off. It's not perfectly held on tight, but it's enough that operators can't easily bump it. All right. I think the way I created value here is, I think with my experience with 3D printing and modeling, I brought that to light here at Solder, and I think my projects can really open the door for future 3D printing solutions here at Solder. The vacuum form project really kind of sparked some conversations about possibly 3D printing our CNC forms to hold our parts on our CNC machines, and I think that would be a great